Solve the following system of equations. If there is a single solution, answer it as an ordered pair, x, y, z. If there are infinitely many solutions, parameterize your solutions in such a way that z is your free variable. Answer using reduced fractions if necessary. So in this particular case, we have a large linear system. So it's linear because all the variables have an exponent of 1, but it's a large system because there are 3 equations and 3 separate variables. To solve a large linear system, you absolutely could use the elimination method or the substitution method. The problem is it's easy to get confused as you're solving using one of those 2 methods and using the wrong 2 equations to solve with, and things get canceled out along the way that aren't supposed to, and it looks like there's infinitely many solutions when there really was supposed to be a single solution. It's a very long and tedious process. There is a method called the Gauss-Jordan method, which changes the system into an augmented matrix, which would look like, in this case, 0 for the x, 2 for the y, and -5 for the z, and -21 on the constant side. The second equation would have the coefficients 9, -2, -8, and -35, then 4, -4, 3, and 11. Once you change that into an augmented matrix, there's a system of changes that you can make. For instance, you can swap any 2 rows, you can multiply a row by a constant, and you can multiply a row by a constant and add it to any other row. But the calculator actually provides a very nice method for solving a system of equations that's large, and that's what we're going to use. So we're going to take advantage of the calculator, and in this case, what I will do is hit the second key and the x to the -1, which takes me into the matrix menu, and go over to Edit, which allows me to type in the coefficients of a matrix. So I have my augmented matrix. I've got 3 rows and 4 columns, so a 3 by 4 matrix is perfect. I don't need to change that size. I just need to update and enter the new coefficients. And if you already have some in there, you can just type over them, just like a spreadsheet. It's just pretty straightforward. Now, as I type those in, I want to make sure I warn you to double check your entries, because if the calculator is doing all the solving, the only way to get the wrong answer here is by entering your matrix incorrectly. But your instructor really wouldn't see that. So after you enter your matrix, you can leave the matrix editor, then go back into the matrix menu again, and this time we'll go under the math menu, and you scroll down quite a ways here until you get to the function RREF. Now it's not REF that you want, it's RREF, row reduced echelon form. So you're going to take your matrix that you just entered, so go back into the matrix menu again, and this time you want names, because that will give you the reference to the matrix that you just entered. And here you're telling the calculator you want the row reduced echelon form of matrix A. All right, so it does those row operations and comes up with the reduced form. So the reduced form in this case is 1 0 0 0 1 0 0 0 1, and then I think it was 1 2 5. Yes. And if you change this back into a linear system, remember everything in the first column is multiplied by x, everything in the second is multiplied by y, everything in the third is multiplied by z. So this is effectively the equations x equals 1, y equals 2, and z equals 5, which is telling you that the solution to the system is the ordered triple 1, 2, 5. And that's all you have to do.